the recording now. Okay. So today we're going to talk about images. So I'm definitely not Emma. I'm not Dieter. I'm not, Belyakov. So I don't have a technical background, but I will try my best to make this somewhat, understandable. But just apologize in advance. It's not going to be quite as like smooth as, one of those people with really savvy technical backgrounds. Plus, I was stuck in clinic until just about 2 hours ago. And then, I had to try to program that very last problem in a hurry, but I did get it to work. And my dog seems to be very excited by that last problem of like the Pomeranian as well. Okay, so announcements. So next week, this is going to be on Wednesday of next week. Hardly be quiet. Okay, it's going to be on Wednesday of next week, 4 p.m. Chris is going to talk about pandas. And then the following week, Belyakov is coming back to talk about 2D list. I will like post the assignment and a video on 2D list. I just haven't gotten around to it this week. The one thing I wanted to point out is like now we're actually starting to get into the new material in Python because up until recently, we've either been talking about data, which isn't part of CS 106A anyways, and the problems we've been tackling actually just relied on material we've learned in code in place. But now we're actually bona fide going to go into the second half of CS 106A. And then just to give you guys an overview, the second half of CS 106A is just talking about different data types, okay? And so during the first half, we talked about, you know, things like Boolean, integer, list, and dictionaries. Those are all data types. And now we're going to talk about some newer data types, okay, starting with with images. And then eventually we're going to talk about other data types such as like strings, files, 2D list, nested list, tuples, etc. Okay. And so for me, who basically have somewhat of a simple brain, okay, I can't remember all of these things in detail. Basically, the way that I tend to remember is each of these data types have some unique properties, okay? But everything that we learned that's fundamental to CS 106A applies to each of these data types, which means even though an image looks like a very complicated thing, okay, you can still save it into a variable. And then you can still loop over an image the way you could do it similar to like a list and a dictionary um, or um, or any other kind of data. And so, at least for me, what helped me was if you just always go back to first principles, that was helpful. And so, again, just wanted to say, the Kudo boards are open, okay? And so, if you guys have a moment, drop these fine individuals a line. If you're English, if you're conscientious about your English, you don't have to write it in English. You can write it in your native language, and then these fine individuals can figure out, your gratitude using like ChatGPT or Google Translate or something. Okay. And then the one last thing I was going to do, I didn't have time to do it because I was in clinic all day, is we're sort of like at the halfway point of the course. And so I was going to actually make a Google Doc questionnaire just to get your feedback about what you think is working, what you think is not working in terms of like the length, in terms of like the slides, difficulty of the problems. The one thing I know that Alexander Belikov really tried to do this year is he really tried to make people do hands-on programming. That's a little difficult with a very, very large group. And then also, we can't like force people to like spend time programming outside of the 2 hours we're spending together. Um, but that was definitely a very conscious effort. He wanted to make it a priority. And so in the questionnaire, if you can give some thoughts or feedback as to how better to encourage people to actually do hands-on programming, I think that would be very, very helpful. Um, and then I think it's useful, to just get some feedback because we're halfway through, which means there's basically the second half. And so if something you think is really not working, at least we have time to sort of like change it. Okay. Okay, so I am going to stop talking about that. And let me find my slides on the list. No, no, not list, images. Okay, so a couple things about images. Um, I just wanted to say I don't think we're going to be here for 2 hours. So hopefully I can give you guys some time back. Okay. Uh, Okay. So you guys can see this, right? Okay. So, all right. So the other thing I wanted to call your attention to is starting from this week, okay, since we're introducing new materials for CS 106A, the other thing that basically Alex and I tried to do this year was last year we just made the slides from the CS 106A lectures available. And at least when I was learning this material, I found it very frustrating. Sometimes looking at the slides, even though like Maron and Chris, they're great teachers, but if you're looking at the slides without any context, sometimes it's very, very hard for me to figure out what the heck they're trying to do. And so, what I'm going to try to do this year is I actually tried a lot of resources to see if I could get you guys the videos to CS 106A. But that's a no-go. But Maron actually said, okay, I can use his slides from the spring quarter of CS 106A. Okay, and so these are actually Maron's slides from CS 106A just from this spring. And I am free to sort of like narrate over them. Okay. I know I'm not as charismatic as Maron, nor as articulate as Maron. Hopefully, I'm slightly better looking than Maron. Okay. But I will try my best. And it's also a learning opportunity for me to actually try to narrate over the slides. Okay. And so I will make the narrated slides available in the Google Drive every week. And so I would encourage you guys to take a look at them before we meet because they'll be helpful in doing the program. Okay. And so I think what you need to know about images. I'm not going to go over all of the slides because there is a narrative version, but just to summarize the main points. Okay. For the image library, this is a CS 106A specific version called Simple Image that's built off of the Python Pillow library. I don't really know much about Pillow. I don't think you need to know much about Pillow. If you want to know more about Pillow, you could probably read about it online. But I just know how to use it. Okay. And so, in order to sort of install a simple image, you actually need to install Pillow first. And then hopefully all of you guys were able to follow the image reference guide that was also in the Google Drive to make this work. Okay. And so basically all of the assignments we're going to be using is using this file called the simpleimage.python file. This file has the code for a simple image. And basically, simple image allows you to upload the image file into like PyCharm or VS Code or some other kind of IDE and then display it and allows you to manipulate basically these images. And so the first thing in all of your code, if you're dealing with image, is you want this line is called from simple image, import simple image. Okay. That just uploads this file. Okay, this is very similar to calling that random number library or like calling the Canvas library that we've used previously. Okay, and so as I said before, image is a type of object in Python. Okay, and so it holds data, and the form of data that it holds are pixels. Okay, and so no matter how big your image is, okay, you could save it into a simple variable. And then you can call this variable anything you want. And then within simple image, there is this command called dot show. And so whatever your variable name is, dot show, okay, this is going to actually display the image that's being held in this variable. And so for people um, who were in my section, I couldn't emphasize this enough. Okay. Whenever you have like a data type in Python, just always save it to a variable. If you don't save it into a variable, it could disappear into the ether. But if you save it into a variable and you don't use it later, nothing bad is going to happen. Your program isn't going to crash. Okay. And so when in doubt, because I think very simply, I don't like to overthink anything. I just like follow a couple simple rules. I just always save like data types into variables. Okay. And and like everything else we've been dealing with, loops, dictionaries, okay. Uh, um, sorry, lists and dictionaries, okay, you can loop over them. Similarly, you can loop over images as well. And images have a couple of properties, okay? Um, so I think it's easier to understand the properties first uh, before we talk about loops. Okay. So basically, when you have an image, okay, usually it's denoted on an XY coordinate. So this is similar to graphics where 0, 0 is at the top left-hand corner. And then as you go towards the right, your X value increases. And then as you go towards the bottom, the Y value increases, okay? And so if we look at this flower, this is made up of many, many pixels. And so one of the properties of images is pixels. And so the more pixels you have, I guess the higher the resolution of the image. And then each pixel is denoted by an XY coordinate. Okay, the first value is the X, and the second one is the Y. And this was something I found very cool. I've heard of the term like RGB, but I never knew what RGB means. But the second property of images is that for each pixel, besides its location, it also has these three values called RGB. Okay, and each of these values, I think they go up to don't quote me, but I think the maximum value is 250. And so the range for each of these values goes from like 0 to 250. And so these are basically the colors for red, green, and blue, which are the primary colors. Yes, Miss Cat.
255.
Okay, thank you. Okay. I told you like my memory is not very good, okay? Because I don't like.
My entire project was based on color, so
Okay, good. Definitely like share with us what you know. But I don't try to overstuff my brain with too many details, otherwise it's going to totally explode. Um, No, I mean, I kid you not, okay? So so I just like kind of know the general gestalt, and then if I need to look up details, I just like look up details, okay? But like 250 versus 255, I don't think like my human eye is going to be able to sort of discern the difference between 250 versus 255. But anyways, in terms of these RGB values, they do go from 0 to 255 for each value. And because these are the three primary colors, okay, since we learn in what, like grade school, high school physics, okay, based on some combination of these values, we could essentially get all the colors of the rainbow and make a very colorful world based on all of these colors. Okay. And oh, I don't know why it looks like this. Oh, I think I accidentally hit rotate. Sorry about that. Okay. Okay. And so basically images have two properties. It has the XY location of each pixel, and then it has the RGB value for each pixel. Okay. So now, we can talk about looping over images. Okay. So similar to previously when Alex talked about looping over um, dictionaries and lists. Okay. There are basically two ways we can loop over, say, a list. Okay. We can loop over via each indices, or we can loop over via each element themselves. Okay. So the way that I think about this, again, my brain works in very simple ways, okay, is I try to draw parallels. And so if I can draw parallels, it helps me remember so I don't have to remember a bunch of extraneous details. I think of each pixel like the elements in a list, okay? And then I think of the XY values like the indices in basically in a list or a key in a dictionary, okay? So if you have a loop like this, okay, that says 4 pixel in image. Okay, I mean, again, these names are totally customizable. You don't have to call it pixel. You can call it like for Dieter and Alexander. That would work too, as long as you define Alexander as an image and then, just based on the position of where Dieter is, you'll know it's a pixel. Okay. And so these names are not very relevant. You can call it whatever you want. And so when you have this kind of a structure of a loop, okay, you're basically looping over each pixel. And the pixel goes from essentially from 0, 0 towards the right, and then goes from next row towards the right, okay, all the way down as such, okay? The second way, the second way is, let me see. I think they talk about this. No, it's in the other handout. Okay. So the second way to loop over, let me change my slides. Okay. So the second way to loop over is similar to looping over the keys or the indices in a list or dictionary, okay? And so this is using XY coordinate of the actual pixel. And so you could tell this pretty easily when you're looking at images because there are two values, there's the X and the Y, okay? And so if you're actually looping over the X and the Y, okay, there's usually a nested loop. Um, because it's very hard to just write one loop, um, basically, unless you're only trying to change the Y value or the X value. But most of the time, when you're looping over the actual XY coordinate, okay, there will be a nested loop like this, okay? And if you look at the syntax is a little bit different, okay? Um, because, when you are looping over the pixels, okay, um, you need the file name of that actual image. Okay. But if you're actually looping over the X and the Y coordinate, okay, you need to have the height and the width of the image. Okay. Um, so the syntax is a little bit different for these two loops. And then, similar to looking at the loops for the list in the dictionary, just by looking at the syntax, you can kind of tell whether you're looping over an element or whether you're looping over the indices. And so most of the time, you don't really need to use this XY looping structure. Most of the time, just by looping over each pixel, and then doing whatever you want, like changing the color, um, uh, that would be sufficient, okay? However, if you're trying to like mirror or create like a second image somewhere, okay, you might actually need to loop over the XY coordinate. Because depending on whether you are trying to reflect your image over the x-axis or the y-axis, okay, one of these value will tend to stay constant, but the other value will change, okay? And so here's the food for thought, okay? In this loop here, Mehron has it written such that you're looping over the height or the y component first, okay? And then the x. So my question is, if he were to write these two lines in reverse, okay, such that you're looping over the x first, which is the width, and then looping over the y, do you think you would get the same result?
It should still hit everything, shouldn't it?
That's what Martha says. Anyone want to agree or disagree with Martha?
My my gut instinct tells me that it's going to be different somehow.
Why?
I don't know. That's why it's a gut instinct, dear.
Okay. Okay. And so I'm trying to see if I can, where is my poll? It's like so hard.
An old one came up, the one about PyCharm versus VS Code.
I know, and then I didn't want that, but so I'm trying to, it's okay. So I'm going to see if I can, okay, I don't,
I
okay,
could stop sharing. I have a button that I can click. Do you want me to?
okay. I'm gonna stop
That's
sharing.
why it's
Okay, and then I'll get share results. Okay, back, and then I will say, okay, so XY looping will be the same. Looping, will it be the same or order matters? Okay, so I'm just going to launch this. Okay, so now, wait, where are, it's very hard when you're like talking and like trying to find these buttons at the same time and um,
I still see the untitled poll 2 up with the
oh,
PyCharm versus VS Code. Shall I close that window?
actually, you know what? Save, don't save. Okay, I got this. Okay, so I'm gonna share. Okay, you guys should see this poll, right? Yes, yes. Okay, it worked. Okay. Um, Okay, so how many people do we have here?
We have 19 including us, so
Okay,
17
so
votes.
so my husband is what boba should I get? I'm gonna call not boba. Okay. All right. Okay. All right. Well, I'm gonna stop. Okay. So, I'm gonna ask Dieter because he's my trusted friend and I think he's really smart. So, Dieter, what do you think? Do you think order matters?
I would say it depends what you do, but in this case, I would say the order does not matter because no matter how you traverse the 2D space, this way or that way, you'll touch every pixel once. It's only when you start overriding some that you might care.
Yes. Okay. So I think, personally, I would never bet against Dieter or Martha. And so, in this case, it doesn't matter. If you're trying to reflect an image, okay, like either in the X direction or the Y direction, then it does matter. But if you're just like trying to say change the color of something, suppose you're trying to change a color of an image, okay, such that you're going to touch all of the pixels once, okay, you can do the X first or the Y first. It's like the commutative property of like multiplication or something, okay. So most of the time, unless you're trying to put the image in like a new place, order doesn't well. Actually, even if you're trying to reflect the pixels, okay, somewhere, order doesn't really matter. I mean, it does matter which one you change, but order doesn't matter. In fact, we have a problem like that, and then I will show you guys that later. Okay, so basically, that's kind of the summary on images. Any questions? Okay,
Just a comment on the order.
yeah.
I think one question that would be important to address is whether you say you want to change the picture. Do you create a new image that's empty where you fill in the pixels, then order doesn't matter? Or do you do it in place and then it matters because you're changing pixels that might be somewhere else on the canvas. And so
Oh,
you need
thank
to
you.
figure out which way to go.
So thank you for reminding me. Okay. So the other property that we talked about for a lot of these data types is whether they are mutable or immutable. Okay. And so things like list and dictionaries, they are mutable, which means like when you change them, the actual original list or dictionary actually changes. And if you want to like preserve the sort of original copy, you actually need to make a copy of it. Otherwise, when you start manipulating your lists and dictionaries, the content of it will change. The same thing with images. Okay. Images are mutable, which means that if I have image of like Chris Peach's dog, okay, and then I started changing random colors of that dog, that that original image's color is going to change. And so if you don't want it to change, you should like save a copy that you can go back to. So that was the one thing I forget. So we actually don't have a very big group today, so we could do it two ways. There's only like Theater and I, and we have four problems. Okay. And so if we do breakout rooms, we can do probably two breakout rooms each for a total of four breakout rooms. And so it's about 4 to 5 people in each breakout rooms. So we could do that, or we could just solve the problems together as a group. It's you guys' preference. I will say though, like Belyakov is very nice. He doesn't cold call on people, but people who have had me know that just to keep things going. I have no qualms about cold calling people. I'm not trying to be mean, okay? But I actually think if I cold call people, I'm not trying to make you look bad, okay? But it does force people to think. And then if you don't know, okay, I mean, if you change your name, I won't know who you are. I'm not going to think ill of you. You have a lot of friends here that you can ask for help. And then if you don't want to answer, you could just type in the chat and say your mic is not working, and then I'll move on to the next person. So, do you guys have a preference as to whether or not you want to do this in breakout rooms or as a group?
The chat has at least 5 people voting for the group, and nobody spoke up for breakout rooms.
Oh, okay. All right. So, I really admire you guys. Okay. And so I have to say, like, right now, my list is in alphabetical order. Okay. And so let's get going. Okay, so let me see. Okay, so let's see. Okay. I might have to toggle between how I share the screen. Okay, let's take a look at the first problem. Okay, where's my Adobe? Uh, why can't I? Oh, sorry, I have way too many windows open on my desktop. Acrobat. Screen sharing has failed. Why can I? Sorry. Dieter, do you have the assignment?
Uh, I think so. I don't know which ones you want to do first, but
Well,
yes.
I was gonna go in order.
Okay.
If you have the assignment, can you just share the assignment? We'll take a look at the assignment first, and then I'll share.
Sure. Now, you're not talking about sand. Is that the
Oh no,
assignment?
no, 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 no. Sand is like,
That was hard. That I messed up so many times. Okay.
oh, okay. Sand is like 3 or 4 weeks from now.
Okay. So I'll share my screen here.
Do you have that Stanford filter?
Stanford filter. I'm not sure what you're.
The code in place filter.
Yeah. Does anyone have that assignment
I
ready on
I
their,
have it open. Do you want me to share it?
yes, Martha, right?
Yeah.
Yeah. So you should be able to share the assignment.
Can you?
Okay, yes, yes, yes. Okay. So since you're so kind to share the assignment, if you wouldn't mind reading the assignment, I'll just give you a buy on this problem because I'm sure you could do this problem.
So we're going to write a program that asks the user to enter an image file name. It's going to then load the file and apply the code in place filter. And to apply that filter, we're going to change every pixel to have the following new red, green, and blue values. So red times 1.5, green times zero point 0.7, and blue times 1.5. So it
Yep.
makes it look a lot more pinky purple and less green.
Yep. Okay. So basically the top is the original picture and we want the top picture to look like that bottom picture. Okay, thank you, Martha. So I'm going to share my screen again. Um, Basically, okay, if you're working in VS Code or PyCharm, you want to upload this entire week 6 images folder because within that folder, there is a file called images that has all of the images you need for the assignment. It also has a couple Oh, if you go to this file here, it says video slides. Okay. Um, that's where I have the slides with a voiced over assignment and then how to install the the Pillow library on both PyCharm and VS Code. Okay, and then that's where the actual assignment is. And then if you look at the starter code ends with this .py. Okay, there's a couple of codes that says examples. Okay, these examples will be referenced in the image lecture. Okay, so if you guys haven't taken a look at these sort of examples, I'll just run them very quickly. So the first one, it says image examples. Okay, if you click on this file, and then I'm in VS Code, there's a triangle here. If you hit run, okay, basically, this is an example that Miron talked about. He starts with a picture of a flower. That's this yellow flower here, okay? And the code will teach you how to darken the flower. That's this one here, okay? And then it will help you darken half side of this flower, and it will change the color of the flower, okay? And then it will make it into grayscale right here, okay? And so basically the filter assignment we're gonna do on the Stanford, if you look and understand this example, you should be able to do that. And then another example he talked about in lecture is this mirror example, okay? This one, okay, starts out with one burrito and then basically reflects that burrito over the y-axis onto the other side. Okay. And so we're going to do a similar example of that, except instead of reflecting it vertically, we're going to reflect it horizontally. Okay, and then the last example, this is kind of cool. This is, I guess, having to do how movies are made. It's called green screen. So look at what this does. Okay. So basically what this program does is you start with two pictures. Okay. You have picture A, which is a stop sign. Picture B, it's a bunch of leaves. Okay. And so it's picking out a certain color within picture A, which is the red in the stop sign. And then it's grabbing the corresponding pixels in this picture of leaves and then replacing all of the red with the leaves here. Okay, so that's kind of cool. And so those are the three things we're gonna talk about. Okay. Okay, so back to our first assignment. So this is the filter assignment. Okay, if we look at the sorry, oops. Okay. Can people see my screen?
Yes.
Okay, yeah, okay. So, you don't have to squint, right?
No.
Okay. So for all of these image files, the first thing we want to do is load this line from simple image, import simple image. Okay. And then we have to pull the proper image from this image file. Okay. So I basically put all the files within this folder so that all you guys have to do is to upload the entire folder and then basically the code should run. But if you guys were ever trying to do a project on your own, okay, this path of where the image is located is very important. Okay. Right now, what this tells you is there is a file called quad.jpg. Um, and simple image can work with JPEG, PNG, TIFF, whatever, basically if it's an image, it can work with it. Um, what this says is this image resides in this folder called images, okay? And this image folder is in whatever directory or folder you're in, which is week 6. However, if your image lives somewhere else in a completely different folder that's not opened in VS Code, you're going to have to add the path to that image, okay? Just to keep that in mind. Otherwise, your program isn't going to work. Okay, so in main, the first thing we're going to do is to, you know, call this default file, which is our quad.jpg, and then we're going to save it into a variable very creatively called images. Okay. Um, okay. We're actually not really going to um, oh, use this helper function down here. That's not very necessary. Okay, so I'm just going to go down the list. Um, Mr. Paul Krieger, can you tell me what do I need to do? Is your mic working? Mr. Krieger?
He did unmute, but I cannot hear it either.
Okay. Okay, so
He says I have no mic.
oh, okay. So how about Alyssa?
No.
I'm just going alphabetically, sorry. Okay. I'll get you started. I'm gonna define a function called filter. Okay. Is it, sorry, filter. Okay. And then what do I want the parameter of filter to be?
X and Y and the colors, I guess.
Mm, think bigger.
Yeah, how do we know what to work on?
Yes.
Canvas, I guess.
Yeah. I mean, um, except we're not working with graphics. We're working
I
with,
know, I know, I know. Get somebody else.
okay.
I'm old
Paul
enough
Um,
to
an
know cattle.
Paul answered in the text. He said image.
Oh, yes. Okay. Yes, we want the parameter to be this image, okay? And so since we saved our image in the variable image, okay, I'm just gonna load the parameter as image, okay?
Image.
And and I want to apply the filter through all of the image. So immediately that should trigger what kind of function? Next, Mr. Andrew Morris. I think you typed something in, except it's hard for me to monitor the chat as well. Mr. Morris?
I am not going to be of much help. I'm ill prepared for this, but
No,
trying to
no,
follow
no,
along as best I
it's
can.
fine. It's fine, but let's just think it through, right? I have this image of the Stanford quad. I want to change the color of every single pixel, okay? If you want to do something multiple times in Python, what do you need?
Ooh.
I mean, what kind of action in Python would allow you to basically do something repeatedly?
The loop.
Yes. Who said that?
Loop.
Loop.
Yes. And so I want a loop. And and we talked about there are two ways to loop over an image. We can loop over by XY coordinates, or we can loop over by images. So, Andrew, if you had to pick, which way would you want to loop over this?
I would assume the XY coordinates.
You
Or
could do that. Okay. That's a little complicated because you have to write two loops. Okay. And since I am very lazy, I'm just going to loop over pixels. Okay. Um, So, so, um, so help me, like, how do I start writing a loop?
Or
Yes. For, okay, I'm not feeling very creative today, so I'm just gonna call each pixel pixel, okay? For pixel in what is the name of my image file? Anyone?
Simple image?
Quad.
What?
Simple image?
No, simple image is how I call that image, but right now my image is saved in a variable, and I want the name of that variable.
Image.
Yes. Okay. So, okay. And so, this line for pixel and image is going to allow me to basically loop over every single pixel in the image. Okay. And for every single pixel, that pixel has an R value, a G value, and a B value. So a red, green, and blue value. Okay. And Dieter so kindly gave us those values, okay? And so basically, for basically pixel red, okay, um, I want to change it to pixel red multiplied by 1.5, okay? And
Right?
then pixel green, want to change it to green, that's what, 0.7? And
Yep.
then pixel blue, this is going to be pixel blue dot 1.5. Okay. Um, okay. So, anything else I need to do? So I have the function here. Okay. I have the function here. I need to call the function in my main program. So, let's see, who is my next victim on the list? Okay, Anita, is your mic working today? Anita? Okay.
She
Oh,
says
mic
no.
not working. Okay. Bella, is your mic working? Bella? Okay. Daniel. Daniel, is your mic working?
Yes, by bad English. I
Oh, it's
think
okay.
you must
Um, I'm
use
more like,
a copy
I
image,
can't speak
copy
your
image,
language. Huh?
uh, um, an image, copy an image, uh,
Okay. Um,
using a
I
copy
want
of
to
the image.
call this function, okay? I want to call this function. How do I call this function? This function is called filter.
In
And
that exercise, we are going to
hmm?
rewrite the original image.
Excuse me?
We are going to rewriting the original the image.
Right.
Uh,
So I basically feed in the original image into this function that's filter, okay? But I need to tell the program I'm going to do that. And so how do I do that in the main program? The way I'm going to do that is I'm going to call this function filter, whoops, not filter, okay? And then I'm going to type in image, okay? So line 15 basically um, sends the image, which is a variable that holds this quad picture into this function called filter. And then within filter, it's going to loop over every pixel and then change the red, the green, the blue value. Okay. Um, so let's see if this works. Ta-da! There you go.
Oh, can we see it?
Oh, sorry. Yes. Okay, I didn't realize it doesn't automatically show for you guys. So I have to share.
I share the window. Ta-da!
Ta-da. Okay. So I have another question. Okay. If you guys look at this code, okay, um, sometimes the function has a return statement. Okay. This function does not have a return statement, and yet my image still shows as having been changed. Can anyone tell me why?
Because the image is mutable. We can
Yes,
change it regardless of the function. It's like Canvas, right? We can change Canvas
exactly.
to other functions.
Exactly. Okay. And so does everybody understand what Martha just said? The
No.
reason why, I do
Yes.
not need a return function. I mean, what would happen if I were to say return image? Okay. Let's just run that. Okay. Basically, I get the same exact result. Okay. I mean, my image is still going to be changed. Okay. But this return comment here is not necessary. The reason it's not necessary is because um, when we make changes to an image, it's changed in place and then it's mutable, okay? And so when we go back to the main function and then use this image dot show, it's going to show us the new image, okay? But if you have an immutable um, data type, okay, you would need this return statement to return it back to main in order um, for you to see it. Okay, so any questions on that?
Do you have any examples what you mean by immutable?
Immutable would be like a integer. Okay. Um, basically, okay, if I were to kind of like define something like, A is equal to 1, okay? And then if I were to feed it A, okay? And then I would say, okay. Um and then I would say, within the program, like A is equal to A plus 1, okay? Um, and so here, okay, um, okay, and then if I were to say print A, okay, and then I would say print A, A here, okay. Okay, I may be able to run this in like the terminal, maybe. Let's see. A equals, what the heck is wrong with my code? Unsupported operand? What? Oh. Equals
You're not passing image anymore to the filter function. So you might need to comment that out or
yeah.
write another function.
Yeah. Okay. So let me see. Okay. Yeah, that's probably better. Okay. So suppose I have like here, in the main function, I define A as 1. And then um okay, let's see. Okay. If you look at the terminal here, right? I print A and then A is 1. Okay. And then if I define another function called, I don't know, plus A. Okay. And then if I feed it A here, and then I say A plus equals, um, Okay, and then if I were to say here A is equal to A, well, I don't know.
Oh, a plus 1 is fine. Then you basically increase a within the
A
function by
A plus
1.
one, and then I would say print A. Okay. And then um, if I were to say re- um, turn A, and then here, if I were to say plus A, A, okay, and then I would say print, well, no, print plus A. I think that would work, right? Let's see. I haven't done
I,
this
I
for
think you have a syntax error in the function, the return. It needs to be indented.
yeah, that's right.
And a is, I don't know if you want to put it in parentheses. You don't need to.
I
It
don't
for
think
the
I need
return.
to, but I just do it for kind of like,
Okay.
okay, okay. So basically, if we trace this program, right? Like in the main function, I have an A that's one. Okay. And so the first time I print A, this is the A in the main function. Okay. And then I basically um, call this plus AA, okay? I basically take this value of 1, feed it into this plus A subfunction, okay? And so my 1 goes into the subfunction, and then within this subfunction, the 1 gets added to another 1, and then there's an A that's within the subfunction. But okay, this value is only defined within the subfunction. Okay. And so if I were to not return this, okay, um, um, basically, if I were to not return this A, it will print the A within the subfunction, but it won't actually print line 18. And so we can try this again. Okay. Okay. So if you look at the output, okay, like when it prints 1, this is the A in line 16. And then in line 17, it's printing this variable A in line 16. Okay. And then I'm calling the plus A function. Okay. And then within the plus A function, I have a print statement. And so it's able to print like A plus 1, which is 2. But because I have no return statement, okay, in the main function, it is not able to print this
For pets.
plus AA because nothing is passed here. Okay. And
Vicky, and
so
furthermore, yeah, if you print A
yes,
again,
okay. And then furthermore, if I were to print A again, okay, it's actually printing the original A in the main function. It is not printing this A that's within the plus A function. Okay. That's an example of immutability because the A in the main program really is not changed even after you pass it into a function. Um, that's kind of like a convoluted way of explaining it, but does that make sense?
Yes, it does. Thank you so much.
Sure. There's also a thread on the forum that somebody who actually asked me about this. Because I had time to think, that explanation on the forum is actually more coherent. Okay. Okay. So any questions on this? If not, we can go on to problem 2. Martha, can you share the assignment 2, please?
Yeah, one sec. Okay. Hopefully you can see this.
Yes. Okay.
So you want me to read it again?
Yes, please.
All right, so we're gonna start by writing a function called find flames in the file forestfire.py that highlights the area where a forest fire is active. So we're going to take a satellite image of Greenland's 2017 fires, and our job is to detect all of the sufficiently red pixels in the image, which are indicative of where fires are burning in the image. In class, in the slides that Vicky has, they did this with red screening rather than green screening. You mentioned green screening. And so we consider a pixel sufficiently red if its red value is greater than or equal to the average of the pixel's 3 RGB values. So when we find a sufficiently red pixel in the original image, we're going to set its red values to 255. So we're going to crank it up to 10, basically, and crank the green and blue values down to 0. So this will make the pixel highlighted and making it entirely red. And for everything else that is not sufficiently red, we're going to convert it to a grayscale equivalent so that we can more easily see where the fire is originating from. We do grayscaling by summing together the red, green, and blue values and dividing it by 3, finding the average, and then setting the pixels red, green, and blue values to have all of that same average value. The slides had a slightly different algorithm for this. That was the NTSB or NT something something. And then once we highlight all of the areas that are on fire in the image and grayscale everything else, we should see an image like the one on the right below.
Yep. Okay. So, okay, and so how did they do the grayscale? They basically summed the RGB value, took the
Yes.
average, right? Okay.
Yeah.
Okay. So, okay, so where is my okay. So we're gonna go to a different one that's is called Forest Fire. Okay. So this is your starter code. So let's see who's my next victim.
I'm not even lesbian.
Okay. So my next victim is okay. Okay, so starting with a file, again, if we're dealing with images, we have to load this line from simple image, import simple image. Okay. And so the starter code gave us this intensity threshold, which is a constant. And so this is basically the value we're going to um, uh, compare. Okay. Basically the average two, I think, right? To see if it's sufficiently red. Is that right? Um, uh, what does the assignment say again? I forget.
It's
So,
sufficiently red if it's greater than the average of, I think it was the red, green, and blue.
okay. Intensity you should determine is sufficiently red to determine it's a fire. Okay, I'm not even sure I use this intensity value. Okay, so so basically, if it's sufficiently red, if the red value is greater than the average value, right?
Yeah, great.
Okay.
Okay,
Um,
well, yeah,
um,
greater than or equal to the average of the RGB values.
okay. Okay, and so I don't think we need this intensity threshold.
No,
I don't know
I think that's a red herring.
why it's in there. Okay. It was in the starter code, but I don't think I used it. Okay. So here we're going to upload um our file name. I think this one, does this have the forest fire file name? And so
Yes, ma'am.
this should, okay. Okay, yeah. Okay, so in the main function, okay, we're going to upload the picture of the forest fire. Okay, and then we're gonna save it, call the original fire. And then we're gonna show what the original picture looks like. That's the original fire dot show. Okay. And then we're going to write a function called highlight fire. Okay. And so this highlight fire is going to do what Martha said. Um, that's this function starting at line 24. It's going to um, do what Martha said. It's going to compare the red value of every single pixel to see if it's going to be greater than the average of the RGB value. So the average of the RGB value is this pixel red plus pixel, I think green plus pixel blue divided by 3. Okay. Um, so Demetrios, how do I write and check if the pixel is um, equal or greater than the average value?
Yeah, so we can do if pixel dot red greater or equal to average,
Okay.
colon, then pixel dot red
We're gonna
uh
set it to max, right?
5, yeah, and then the other two
And then
should be
pixel green is equal to 0. And then pixel blue is equal to 0. And then what happens if it is not that bright red?
yeah. Then else we need to set all three values equal to average.
Okay, so set all three values equal to the average. So sorry. So pixel red is equal to average. Pixel green is equal to average. And then pixel blue is equal to average. Okay, and I'm missing something here. I am missing one thing. Um, because I want to loop over every single pixel. So what am I missing here?
Yeah, for pixel in image.
Yes. Okay, so on for pixel in image. Okay. So I think all of these needs to be indented, right? Okay. 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 Do I really need this return image here?
Well, no, yeah, we said before it's mutable, so
Right.
yeah.
Okay. And so well, I mean, we can leave it, or we can comment it out. Okay. And so in our main function, this will display the original image. Okay. And then it's going to take this image, put it into the highlight fire function. And this is going to run it through a for loop of every single pixel and then pick out the ones that are sufficiently red and then make them very bright red and then everything else change it to a grayscale. Okay. So
Vicky, a comment on the return here. I know we talked about them being mutable, but we are reading the image in within the function. So even though it's a mutable image, it only lives in that function. So if we go back to the main loop, it would disappear. So that's why we're returning. That's why we return it, and that's also then why we have in line 50 we assign the return to a new image.
line 50.
Yeah, when we call the function. Oops, sorry.
Oh, line 36.
Uh, I have maybe I messed up my in the main. There in the main, don't you see highlighted fire equals, yeah, 59.
Oh, yeah, yeah, yeah. Yes, yes, yes. Yes. Okay. Yeah, this.
So at
Um,
line 59, highlighted fires is not defined yet until you actually return it. Then it becomes an image available in the main, and we create the new image highlighted fire.
correct.
Before it
Correct.
didn't exist.
Correct. Does everyone know what Dieter is talking about? If not, please ask.
Right, I get it.
Okay. Um, Anyone else? Okay.
Can you pair like use like in a different way to explain it? I kind of got lost a little bit when you said like about the return. What
Okay. So, well, do you want to try explaining it, Dieter?
Well, yeah, I don't know if I have much different words, but if you
like
show
is it
us the
better
function.
you always have return then? Is that what if I'm understanding correctly? Is that what you're saying? Like it's always better off to just leave it and just put return image, whether it's text or images.
It depends what it is. Image is mutable like a list. So if the list already exists before you're doing the function, the work on the list, then you don't need to return it because the list already exists. You're doing work in your function and you're changing the list, even though it lives in the main program. And then you don't need to return anything when you return to the main program. The list is still there. All the work you've done is still there. Same with the image. If the image lives already in the main program, like the original file, that's already there.
Right.
If you were changing that image, it would survive. You wouldn't need the changes would survive. You wouldn't need to return it. But the highlighted file has not been defined in the main program. It only starts existing in the function. And if you didn't return it, it will just disappear because it didn't exist before.
Before. Right. Got it. Thank you.
Sure.
Well, let's run this program and then we can tweak the code. I think like tweaking the code might making it slightly um, more clear. Okay. And so, okay, if we run this, okay, if we run this, um, I basically get two images. I get the original, okay, and then I also get the highlighted, okay. However, if I were to change my code, and then if I were to say um original fire dot show, okay. So here I have three show statements, okay? I'm showing the original fire, okay, for the first time. And then I'm passing the image into this function where it's picking out all the red pixels, okay? And then it's returning the image and then we're showing the highlighted fire, okay? And then I'm showing the original fire again. What do you guys think this third original fire is going to look like? Is it going to look like the original or is it going to look like the highlighted? And why? Anyone?
I think the original, because well, maybe not. Because in highlight fires, no, I think it'll look like the original. Because in the highlight fires, did we rewrite that?
Um, can you scroll up so we see the argument that you pass? You see it's
The argument that it
the
has is file name,
yeah file name. We're not actually passing an image.
right?
Yeah, so you're rewriting, no, you're returning an image. You're returning per pixel in image. You are returning something.
Okay.
You've overwritten the image, so you're going to see the highlighted.
No.
No, I think it's original.
Yes, Martha is correct. Okay. If you run this, okay, it actually returns the original. And the reason why it's returning the original is because into the highlighted files, we're passing the file name. We're actually not passing the original image. Okay. If I were to instead pass this, if I were to say, if I were gonna pass a original, if I passed it original fire, okay. Let's see if this is gonna work. Actually, this did not work. Bu- 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 bu.
You're still creating a new image. So on line 36 here, if you need to comment that
Oh,
out
oh
if
yeah,
you
yeah.
want to,
Thank you.
and
Okay.
you need to
Yeah,
pass something called image rather than original.
yeah. And so if I were to, but I'm not, I didn't define image anywhere.
Right, you're passing it now.
Yes, I'm passing on the image. Okay. And so if I'm passing in the image, okay, instead of file name, mm, this didn't work. Um, I think it only gave me one image. Um, why did it only give me one
In
image?
the line 59, we should change the parameter to the image to the original file instead of the path of the file.
Let's see. Original fire. Okay, let's try this. Yes. Okay. This worked. Yeah. Okay.
We don't see your images though.
Yeah. So, so yes, thank you. Okay. And so this, okay, it showed us the original image. Okay. And then it showed us the highlighted image, okay? And then when I printed the second original image, it actually gave me the highlighted image. And so the difference between what we did here and the other code is here, okay, we are actually passing an actual image into the highlight fires function. Okay. And so if we're passing an actual image, okay, this image is actually being changed in place. And so even when we're showing the original image, since it's changed, we're not going to be able to get the original image back. Okay.
And that's why they kept passing the file name and reloading it so that we weren't changing the original image. Okay, I did not get that
Right.
until really
Right.
just now.
Okay. And so, um, which is why in the main, okay, they actually pass the actual path to the image rather than the original image. Okay. And so one last thing before we go on. Okay. Let's say if I commented out line 48, if I commented out line 48, okay, what do you think is going to happen? I think the program is going to crash. Okay. Um, oh, it didn't crash. Mm, wait, let's see. Okay. Oh, because here I'm still passing in file name. I'm still passing in image. Okay, I have to change it back to file name. Okay, yeah. Okay. It didn't crash. Okay. But what happened here is I only got one image back. Okay. I didn't get any other image back. I only got the original image back. And basically that's what Deirdre was saying is, oh, wrong screen share. Okay. Okay. If I'm passing in the file name, okay, um, and I'm not returning anything, this highlighted fire is not created. And so, um, and so if I'm not returning an image to this highlighted fire variable, there's really nothing to show. Okay. Um, that's why we needed this return image here uh, because we don't have the return image here, okay, there's really nothing that's passed back to this highlighted fire variable. And so there's nothing to show there. Hence, there's like different ways of like writing this to make it do what you want. You can um, pass in either the file name or you can pass in the image. Either one will work. Hopefully we've beaten that one to death. Any questions? Okay. If not, Martha, can you share problem 3?
Yeah, one sec. Get to the right screen. Problem 3, reflection.
Oh, can you share your screen,
Oh,
please?
are you guys seeing it?
Yeah.
I'm not.
It's beautiful.
Yes, we see it.
You might need to switch your window, Vicky.
Okay. All right.
All right, so this is showing a beautiful mountain. So we are to write a function that returns an output image that is twice the height of the original. And the top half of the output image should be identical to the original image. And then the bottom half should look like a reflection of the top half. So the highest row on the top half should be reflected to be the lowest row in the bottom half. This results in a cool effect.
Cool. Thank you. You should be a radio announcer. Um,
I have a face for radio.
no, and then you definitely have a voice for radio too. Okay, so we have this. Okay. So here again, we have form simple image, import simple image, and we have this function called make reflected. And so please note here, we're not passing in an image, we're passing in a file name. Okay, and then we have the main function. The main function is showing us the original image, okay, which is the Mount Rainier. And then it will return um, uh, something from this make reflected and then show us that. Okay. So let's see, this is not a return mirror. I think this is oh yeah, it is return mirror. Okay. So where is okay, so who's my next victim? Coco, is your mic working?
Yes.
Hi, how are you?
Good.
Okay, so I'm gonna get you started in this reflective function. Okay, I'm gonna have image is equal to simple image. Okay, and then it's gonna take the parameter file name. Okay, and then here we're gonna define a width variable. Okay, this is the image's width. And then we're going to define a height variable. This is the image height. Okay. This is the original image's width and the original image's height. Okay. And then I'm going to define a new variable, which I'm going to call here mirror. Okay. And so mirror is basically a blank new image that's going to be twice as big as my original image. Why do I need it to be twice as big?
You mean why?
Mhm.
Because that's what the question asked. It says that.
Well, because we are reflecting it, right? Because if you make this new variable mirror the same size as your original image, it's not going to be able to accommodate like basically two images. Okay.
Right.
Hence the way to make this twice as big is you save it into a variable. Okay. you use this command like simple image dot blank. Okay. And so this blank image has a width and a height. Okay. And so tell me if I want this to be twice as big as my original image and I'm reflecting it over the x-axis, um, what's the width and the height relative to the original image?
You mean like just times two for
Mhm.
width and the height? Well, we start with the weight, I would believe, right? Or does it
Yes.
matter? Does order matter?
Um, does your width change?
Yeah. Wait. Wait, no. Probably no. Just the height, right? Because you
Right.
said just the
Right.
height
And so what would be the new height of this image?
times two.
Yep. Excellent. Okay. You are on a roll. Okay. And so now this mirror is essentially this new empty image, okay, that I'm gonna put two of my original image in, okay? And so if I want to reflect something over the x-axis, okay, I would need a loop. This is the one case where a pixel loop would not work because I need both the x and the y coordinate. Okay. And so if I'm reflecting something over the sort of like x axis, okay, which is the horizontal axis, do you think it's the x component that's changed or the y component that's changed?
The y component.
Good. Okay. So I'm gonna write my loop. Okay, I'm gonna say for y in range, height, and then for x in range, width. Okay. And then I'm gonna use this um, command called image get pixel. Okay. Get pixel, basically, if I specify an XY component, it basically grabs the pixel at the XY component, and then you can tell it to put it anywhere else on your like blank image. Okay. And so I'm gonna call this like image.
Dispensary.
Hmm?
Nothing.
Oh, sorry, I'm gonna call it pixel. Okay. Um, so pixel is a variable, and then in this variable, I'm going to grab a pixel at the XY coordinate, okay, from this image, okay? And then since Coco said that the X component doesn't really change, okay? Um, okay, basically for every pixel that I grab, okay, I have to put it down in two places. I have to put it down in the top image and I have to put it down in the bottom image that's reflected. Okay, so the first command, I'm going to put it down in the top image. Okay, this is set pixel. Um, this one is easy. Okay, this is essentially X, Y, and pixel. Okay. The mirrored part, this is a little bit harder. This is set pixel. Okay. So we said the X component stays the same. The Y component is actually your height times 2, subtract Y plus 1. Okay. I know this is not that intuitive, but basically, to get at this formula, okay, is if you have, say, a pixel at, say, y of 0, and then let's say your height is like 200, okay? If you had a pixel at 0, okay, um, let me just double check one thing. Shoot. Uh, whoops. Okay. Um, so, Dieter, can you explain this part better? Because I don't think I can explain it that well without
Sure.
a
Uh,
picture.
yeah, okay. So the question is, let's look at the
I'm trying to
pixel.
find a picture, but
Let's look at the pixel in the first row.
row.
Its index is 0,
Yeah.
right? Because in an image like in a range or in a list, the index starts at 0 and it stops before you actually reach the length of the list or the height. So the max index is not the height, it's height minus 1. And so if we have twice the picture, it goes from 0 to 2 times height minus 1. That's the absolute maximum index we can put a pixel because there's 2 times height pixels. It starts at 0, so it must be 2 times height minus 1. And now the y is basically just going line by line. The first line would be index 0, so y equals 0, and that will put us at the bottom of the pixel. And the next row we do is y equals 1. And so then we have height times 2 minus 2. So we move up from the bottom as we fill them in.
Okay. Do you think you can give like a specific example? Like uh basically if your height is like 200 and then if you start with 0, where would that reflect? I'm trying to find a picture that might illustrate this better, but
Okay, so yeah, let's assume the original pixel, the original image is 100. Uh, so the height is
yeah.
100. So if you go and you look at the y, what are the y's as we stop through that image? It goes from 0, 1, 2, 3, 4, all the way to 99. And there it stops because we know when you have for y in range of height, it goes from 0 to height minus 1. It has height number of lines that you go through. So it goes from 0 to 99. That's the range or the values that the y can assume.
Mhm.
And now when we, in the first top half, basically we just, line 1 goes to line 1, line 2 goes to line 2, and so on, all the way to line 99. But now we have an image that's twice as high. It's 200. So the bottom index is 199 because it needs to be one less than the number of pixels. So the first row with y equals 0 needs to go to 199. So 2 times height is 200, the y is 0, so minus 1, that's 199. And then as the y increases, you're moving up, you're decreasing the index for where you fill it in.
Okay.
Was that clear?
So I'm gonna show this picture. Hopefully this picture makes it a little clearer. I don't know if because here you basically have like a well, okay. This is actually reflecting over the y. It's not reflecting over the x, but it's a similar idea, okay? Suppose you have a dot that's at y is equal to 0, but x, I don't know how to read this.
This is a confusing picture. I'm not sure what they're trying to show
Yeah,
here.
I don't think this picture helps. Okay, never mind. Yes, because ChatGPT was once able to generate a good picture, but that one was not all that helpful. Um, Let me go back to share this screen again. Okay, so wait, it's not showing my, whoops. Why is it not showing my code? Uh-oh. Duh. Okay. It is not showing my code. I think we're having that problem we had. Shoot, I shouldn't have like sorry. Why is it not? Are you guys seeing anything? No? Shoot. Let's see, my screen. My screen. Resume share. Resume share. Your screen is paused. Okay, share. What? Um, Sorry, I don't know what happened to this. Um, you're not seeing my screen?
Oh,
No,
not at all.
it just shows you've started screen sharing, but maybe it's not sharing window versus program versus
Let me see. Okay, you can
your
see
desktop
this.
now.
Okay,
Desktop.
right. You're seeing my desktop, but you're not seeing my VS Code window.
Now we are.
Okay.
Yeah.
Sorry, I don't know what happened. Okay. Okay. Sorry. But the main crux of this program is okay, um figuring out, how to code this Y coordinate. Okay, and then here we do need to return, okay, this new image, which is mirror. Um um Back into the main. Okay. And so if we were to run this, okay, um, this is what your output looks like. We basically get two pictures. Okay. The first one is our original, like this. And then the second one is the mirrored one. Okay, with the original on top and the reflected on bottom. Okay, any questions there? Okay, so I thought we were gonna finish early, but hopefully we'll just finish on time. Okay, Martha, do you mind sharing the last question?
Yeah. Let me the sharing. Okay. You should see it now.
Ooh.
Yeah, this one kicked my butt. I got as far as just making the square.
Yeah, so
So
this one is really confusing. Okay, there are multiple ways to do it. I have to be honest, I had about an hour and a half. Well, previously I've done this problem before, but it's been a long time and I did not save my solution. And so I had to recreate it from scratch, and I only had about an hour and a half before clinic and when our session started. And so I don't know that this is the most elegant, but it is functional. I did test it and then it works. And so if anyone has a better solution, was wondering if anyone actually got this to work. And then want to talk about how they got it to work. Dieter, did you try this?
No, I have to say I did not.
Okay. Okay. So, okay. And so you can see my code, right?
Yes.
Okay. I'm not gonna be mean, since we only have about 15 minutes, I'm just gonna walk over what I did. I'm sure if like Belikov the Russian were here, he would probably be like frowning on my code. But hey, I never said that I'm a very elegant coder. As long as the code runs functionally without errors, I consider that a win. Okay. So in the starter code, they give you all of this stuff, okay? Like from simple code, import simple image. And they actually give you these constants. And so the n rows tells you that there are two rows, okay? And then the n column tells you that there are three columns, okay? And the patch size, each patch, basically each patch is a square, okay? And so the patch size is like 222, okay? And so this patch size refers to a single dog picture. And for those of you who are curious, that dog is named Simba, and then I think it's like Chris Peach's Pomeranian. And so they also gave you these called width and height. And so looking at the width and the height, can somebody tell me what these width and height are referring to? Um, they're definitely not the single patch, right? Could somebody tell me what these width and height are referring to?
The tiles that you're basically going to repeat the picture across the new image, kind of the Warhol effect,
Right,
each tile being different color.
right. Okay. Um, and so basically, this width and height is referring to the new image that's going to be able to accommodate all six of your tiles. Okay. And then here we have this patch name, which is referring to the image of Simba. Okay. And so patch name only has a single dog. Okay. And so in the main program, this is what I did. Okay. Again, I'm not saying this is the best solution or the only solution. But it is a functional solution. Okay. I defined a variable called final image. Okay. And right now, this final image is a blank slate. Okay. And I wanted to have a width that can accommodate um, three side by side um, patches and two rows of patch. Okay, for a total of six. Okay. And then what I did here is I defined actually a list. And then this list is a filter um, called filter. And then within each element of the list, okay, is a data structure we haven't talked about yet. This is called a tuple. And so a tuple is similar to a list, except it's ordered. Okay. And so basically within these tuples, I basically gave it a bunch of like RGB values that would correspond to these colors. Okay. That's what this filter is. Okay. And the key for solving these problems, this particular problems, okay, is basically you need to write two nested um, for loops. Okay. The first for loop basically loops over the rows and the columns of each patch. Okay, that's this outer for loop here. And then the second for loop basically loops over each pixel within each patch. Okay, this is basically the crux of the problem is to realize you actually needed two nested for loops. One one that sets each patch in their right place. And the second for loop, okay, loops over each pixel and then changes the color. Okay. And then they actually gave you this function called make recolored patch. And so the make recolored patch takes in three arguments: red, green, and blue. Okay. And basically, it will take in these values from each tuple, okay, into the make recolored patch, okay? And so each patch is going to have a different um, red, green, blue value, and then it's actually going to um, do some calculation, calculate the average based on the value that you give it, and then comes up with some like color of like red, green, and blue. Okay. Um, um, I didn't write this recolor patch function, but that's essentially what the function does, is that it takes in different RGB values and then loops over every pixel and then colors the pixel. And then it finally returns um, this image, which is the patch. Okay. Okay. So the first for loop, we're looping over rows in range of n rows, okay, and then column in range n columns. And so this is going to loop over each row twice because there are two rows, and then loop over each column three times. Quick question. Does it matter here if I were to loop over the column first or the rows first? Anybody? Dr. Carter, what do you think? Do you think it matters if I were to loop over the rows and the columns first? Okay.
He doesn't have a mic.
Okay. Uh, Momina, what do you think? No
This
mic?
case, no.
Huh?
In this case, no, because we're mirroring the entire image, and
Excellent.
all the new colors will be the same.
Thank you. Excellent. Okay. Yes, it does not matter. Okay. And so then I actually created a variable called filter index. Okay. So this filter index basically um, I take each row, okay, multiply by the total number of columns, okay, and then add which column I'm dealing with, okay. And so what this filter index gives you is a number from 0 to 5. And so if you're on the uh, top left-hand patch, okay, that will have a filter index of 0 because I will be in column 0, okay, and then row 0. And so 0 plus 0 would be 0, okay? And then in the top middle one, that will have a value of 1 because I'll still be in row 0, but then this column will be 1, okay? And so you'll see why this filter index is useful later. But each patch basically gets assigned a unique number from 0 to 5, okay? Like 0, 1, 2, 3, 4, 5, okay? For a total of 6. And so the reason why this filter index is useful is it actually help us unpack this tuple. Um, corresponding to the particular patch. Okay. And so we'll probably talk about this later, but if you look at the element in this list of filters, right? Each element is a tuple, and the tuple has three values corresponding to RGB. Okay. And so I call them red scale, green scale, and blue scale. Okay. And so this line 27 here is I'm basically taking each element of this list of filters, okay, and then unpacking them onto the corresponding filter index. And so basically, the filter index, which is the patch 0, will get this first one. Number 1 will get the second one. And the third one will get this, and that will be red. And then the fourth one will be the bottom left-hand corner. That'll be a cyan, and then orange, and then lime. Okay. Okay. And then um line 28, okay. Line 28 is I basically take these values which I got from the unpacked tuple and feed it into this function of recolored patch. And so I'm using those RGB values, okay, to color a particular patch using this subfunction here, okay? And then, this is our second nested loop right here. And so the second nested loop here, we're actually looping over the pixels within each of those patch, okay? And so here I'm looping over Y first and then X, but you could loop over X and then Y first. Okay. Doesn't really matter. Okay. And so what I'm then doing is I'm using this get pixel command. Okay. If you remember this make recolored patch, right? Basically takes a patch, changes its color, and then it returns the patch. Okay. And so I'm basically grabbing each of the XY value of that recolored a patch at position XY. Okay. And then I am setting that XY pixel onto my final big canvas. Okay. And line 33, 34 is basically calculating where the pixel should go onto that final canvas. Okay. Um, and then like here, line 35 through 38, okay, I'm actually putting those pixel onto the final image, okay, at the position of XY that I calculated. And I am basically setting the RGB value based on the value that I got from the recolored patch. Okay. And so this is going to loop over every pixel in every patch. Okay. And then finally, at the end, I'm going to show this final image. Okay. Um, so just like big picture, the way to do this is we're going to generate this um, I guess, canvas that can accommodate 6 different pictures. Okay. And then I'm going to assign a unique value to each of those pictures. Okay. And I'm going to unpack a tuple that's within a list so that each of those patches will be of a different color. And then I'm going to use this subfunction called recoloring to change the color of those patches. Okay. And then I'm going to loop over each pixel within the patch and then grabbing those pixels and then putting them onto the final canvas with the right color in the right position. Okay. And so let's see what this looks like. Okay, so let's see. Okay. Uh, do you guys see the dog?
Yay!
Yeah, I mean, this problem is very hard. And then I don't know if I did it quite the justice that it deserves. But that's how I did it. Um, Basically, if you don't use the tuple, you could probably use a random color generator to try to color the dog's different color. But um, um, I don't expect you to kind of remember how to solve that problem, but I think the key to that problem is basically understanding you need two nested for loops. The first for loops is to put each patch in their right position, in the right column, in the right row. And the second nested for loops is to loop over each pixel to give it the appropriate color. Basically, if you can remember that, I think, that's the main point of that problem.
So Vicky, did I spent a lot of time working on getting a square patch. Could you just flash that up also, or because the image had was a rectangular one, and so I didn't get to all the coloring, but did you do anything special with the making it square before?
No, 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 I didn't, at all. In fact, I don't think it really
It didn't
mattered,
matter.
that much. Well, basically, no.
You just read like the first part of the image until it makes a square, and then you end up like you get that for the recoloring, and then you move on to the next one. So you're just going from like you're just taking a sample of the patch size, however large it is.
No, because each patch, is 222,
Yeah,
right?
but the image you're working from is like 300 by, I don't know, 230 or something.
Right. I look at the image and I see that. And if you compare the result, even in the handout from the
Uh-huh.
image,
Uh-huh.
basically you start at the upper left, index 00, and you just crop it to whatever the
You just
square patch is.
stop at the patch level.
Yeah.
Okay, because I was like, oh, I think I need to make it centered. And so I
Oh,
subtracted, I made
no.
it more complicated. And I was like, oh, okay, now I have to make an image that's centered, and then I can work on coloring. And that took
Oh,
a while.
yeah. Yes.
Good practice.
Um, in fact, like, if you didn't mention it, okay, I wouldn't have realized that the basically actual Simba picture is ever so slightly larger than the tessellated Simba picture, because you're right that the original Simba is a rectangular image, but I just make each patch fit on the
Right,
final
right.
thing and then cropped it kind of. Okay.
Great, great. Thank you. Yeah, I was trying to do fancy cropping, and that slowed things down, but I you can get it working with the different filters first and then worry about what adjustments you want to make to the patch. So great.
Right.
Thank you.
I'm sure if Alex were here, he might have some other fancy way to like preserve the size and stuff like that. But okay, this is like sort of the limit of what I could do. And then he didn't want to talk about images, so
This was great.
yeah, like left
Uh,
stuck. And
yeah,
so
if you're
hopefully you guys learned something. Sorry, Dieter.
Yeah, just about the pillow library. If you look at that, you can actually resize images and take sub images. So there's pre-written functions for that. So you could basically say, I want to squish it down to my whatever square grid I want to fill. That would be an option. Or you could read it and decide what we have now as the patch width constant. You could make that a variable.
Yeah. Okay. Well, hopefully that was somewhat coherent for all of you guys. I will post the code and the video. I'm gonna stop recording.